Hi everyone, my name is John Sayer and I'm a Technical Marketing Manager here at Autodesk. I'd like to welcome you to today's presentation where I will be providing a technical review of the Autodesk Drainage Design for Infraworks 360 solution. During this short demonstration, we will focus on several key aspects of planning and conceptual design processes used on drainage projects. Today we will focus on several key aspects of Autodesk Drainage Design for Infraworks 360. The first key area we will look at is drainage area selection. We will be able to select a point on our model, and Infraworks 360 will show us the drainage area to that known point. Next, we will look at culvert placement and preliminary design. We will also look at drainage structure placement along a design roadway. And last but not least, we will look at the quantities from both the culvert and the drainage structures and pipes that we placed in the model. I will give you a brief demonstration of how all this works, then have a quick summary and time for some Q&A at the end. But before we start, I would like to throw out some of the goals for today's sessions. My main objective is to get you exposure to the drainage design features for Infraworks 360. I will show you the subset of capabilities that we just went through in a demonstration and stick to that agenda. I say stick to that agenda because we have a short amount of time here to cover just some of the capabilities in today's demo. And I definitely want to be sure to get you your questions and address those questions at the end. So let's get started. The project that we're looking at today is pretty straightforward. We've been tasked to find out how much water is draining to a specific location and figure out how much or how big of a culvert we would need to pass the flow coming to this point. This road has overtopping issues, so that's why we've been tasked with figuring out this information. In case you were wondering, I gathered the initial model data from the Model Builder preview inside of Infraworks 360. It provided me the USGS DEM and an image in less than 15 minutes, so the time it took to gather the initial data was minimal. So I'm going to go ahead and create a drainage area or a watershed. So I'll select the point where everything flows to and select enter. Now while this is doing this in real time, I want you to think about how long it would take you to do this in the method that you've done it in the past. And I think that you'll be pleasantly surprised as to how fast that Infraworks 360's drainage design is going to actually show us our watershed. So at first glance, if I look here at my watershed, there's a main highway here, 65. I would have thought that everything would have been on this side of the road, but that is not the case in this instance. This drainage area goes way outside the boundary of where I would have actually thought that it would have been. So very, very quickly we're able to gather a watershed or obtain a watershed from the data that's here in our model. So now that we've got our watershed, I want to size a culvert underneath the road. So I'm going to select my road and I'm going to add culverts on my road, and it will automatically add a culvert where it sees that it needs one. Once the culvert is in, then we've got some things that contextually show up. We could see our pipe or our flared in sections on both sides. If we turn our surface opacity, or if we select our surface opacity button here, then we can actually see the pipe that's going underneath. Okay, well I know this pipe is not big enough, so there's some things that I can do with my watershed that will enable me to go ahead and size this culvert preliminarily to see what size I'm going to have. So I'm going to select my watershed, and I'm going to select my hydrology method. I have two different methods, rational and regression. We're going to use the rational method today. I'm going to use a weighted coefficient. I'm just going to use one of 0.25 today. And I'm going to select and use a rainfall intensity of 10.2. Once that's done, it gives me my Q100. It does only figure right now for the Q100, so that flow is what I want to push through this culvert. So I'm going to move in once I've got it calculated. I'm just going to select that culvert. Now, it's going to automatically size the culvert to pass the flow, or it's going to start giving us information here in the blow up of the culvert so that we can adequately size the culvert. So I know that 74 feet per second is too fast, and I know that my headwater depth of 19 feet is too high. So I can start to do a few things. I can add barrels. So I'm going to add another barrel very quickly onto this culvert. So I'm just going to pick barrels here, and I'm going to hit the up arrow, and it will add another barrel. Now, once that barrel is added, you can see that the upstream and downstream information has changed. So the velocity has changed, the headwater depth has changed, and we're starting to get down in the realm of what we want. Now, I can go up to 3 barrels. So if I add a third barrel, I'm now looking at a 2.7 foot depth and right at 25 feet per second. Okay, so what I'm trying to show you is that this is very quick and gives us very quick results as to how big that this particular culvert needs to be. So I can not only use circular culverts, but I can use box culverts also. All I have to do is change my shape to a box, and it will generate a box culvert for all 3 of the barrels that we've added. So now we're looking at box culverts, and you can see that the upstream and downstream information has changed once more. Now we can also grip edit with our arrows the size of these boxes. So I can drop that down to 120 inch by 120 inch, and it not only sizes this box, but it sizes all 3 of the barrels to the same size. If that's the size that we like, then we can look at our information that it gives us upstream and downstream, make sure that we're meeting the criteria that we need to meet, and we are ready to take this into Civil 3D and continue on with our design process of that culvert. Now, we're also going to look at this design road. I've got my culvert done here. I want to go ahead and take a quick look at this design road just so that you can see what's going on with it. This road itself does have a profile. All right, so if I select the road, I can look at the profile view, and this road has sags and crests for low points and high points inside of the road. So you can see that here in my profile view. So if we wanted to see what a preliminary design would look like for inlets and pipe, what we could do is select our road, right-click, and select Add Drainage Network. What it does is it throws in, according to our high and low points in our road, it throws in some pipes and structures. All right. Now, these spacing and the way that the conceptual design is done is controlled by a design criteria file that can be modified. And you can adjust spacing, things of that nature. Now, if we were trying to show this conceptually, we could come on down and actually select a pipe or a structure and add a manual pipe and structure to show daylighting. So I could come back and I could select pavement drainage, and I'll just zoom in here and I will pick one of my structures, and we'll pan down and around and set the end of a pipe. Let's select end run there. Now you can see that it does daylight right here. With our surface opacity, it makes it really easy to see that this pipe is draining away. So I can simply select the inlet that it sets at the end and delete it. And then I can manipulate this pipe to move it back and forth. Now, whenever this was being designed, this pipe is definitely going to have to come up and show itself as daylighting. So I can grab it and actually pull it back to where it would actually daylight, and then maybe just kind of raise it up just to show, so that the effect that you see conceptually is that it is daylighting. And again, like I said, we could move this up and down until we got it to where it would look correct. I'll go ahead and pull it back here just a little bit. Now we can see that we're daylighting, and we can see, if I lower it back down a little, that the pipe is actually draining. Okay, you can tell right there that it is draining. So the software itself will put the drainage pipes and structures in for you according to the low points and high points, and then we can add our discharge pipes where we think that they need to be added. Now this would actually be discharging back down to our drainage area for our culvert. So this would be a great conceptual design to start with. Now, the last thing I want to talk about today is quantities. So, and this is pretty straightforward. If we want to see quantities for, say, our culvert road, and we want to know what kind of quantities we have for that, we can select our culvert road and then just pick quantities. Okay, and we'll select our culvert road again, and it tells us what quantity we have for that road. Now, what would be even better is if we could select our design road and see our count of our inlets. And lo and behold, we can. So we can see length of pipe, we can see our manholes, we can see inlets, things of that nature. So it's a great way to check for quantities. It's a great way to, I think you can see in using Drainage Design for Infraworks 360 how it can definitely be a good time saver. To summarize, what is Autodesk Drainage Design for Infraworks 360? Essentially, it is a software solution that helps civil engineers accelerate design and analysis of drainage associated with roadway design. During our demonstration, we used it to create a drainage area for analysis of a culvert, created a conceptual culvert to carry the flow from the drainage area, placed drainage structures and pipes in a design road, and gathered quantities for all at the end. As for the business benefit, Drainage Design for Infraworks 360 is easy to use, very intuitive, and extremely powerful. Its numerous features will enable you to speed the conceptual drainage design process as well as more quickly evaluate numerous design alternatives such that you can present your client the best drainage design concept possible.